This lesson shows how to graph function families with transformations. There are sets of functions called families. Each family has a parent function. Functions in the family are transformations of the parent function. A good way to demonstrate transformations is with the absolute value function. The graph of the absolute value function is a symmetrical V-shaped figure opening upward. The base of the V is called the vertex. The lines on either side of the vertex are the legs. The right leg has a slope equal to +1, and the left leg has a slope equal to -1. This is the parent of all absolute value functions. One type of transformation is a translation. If you replace x in the function with x plus or minus a constant, the graph translates right or left. For example, if you replace x with x minus 2, the graph translates 2 units to the right. The vertex is now at +2 on the x-axis. Be careful. It's natural to think x minus 2 would shift the graph to the left, since left is the negative direction on the x-axis, but the opposite is true. If you replace x in the function with x plus 1, the graph translates 1 unit to the left. The vertex is now at -1 on the x-axis. If you add or subtract a constant to the function, the graph translates up or down. For example, if you add 1 to the function, the graph translates 1 unit up, and the vertex is now at +1 on the y-axis. If you subtract 2 from the function, the graph translates 2 units down, and the vertex is now at -2 on the y-axis. If you multiply the function by a constant, the y-coordinates of points on the graph are multiplied by the constants, but the x-coordinates are not changed. This causes a vertical dilation of the graph. For example, if you multiply the function by a number greater than 1, like 2, the graph is stretched vertically. The legs are steeper, with the slope equal to plus or minus 2. If you multiply the function by a fraction like 1/2, the graph is compressed vertically. The legs are flatter, with a slope equal to plus or minus 1/2. Another type of transformation is a reflection, and the square root function is a great function for demonstrating reflections. The shape of the function is easy to understand. You can't take the square root of a negative number, so the graph starts at x equals 0. Then the square root of 0 equals 0. The square root of 1 is equal to 1. And the square root of 4 is equal to 2. The graph of the function is a gently sloping curve up and to the right. If you multiply the function by -1, the y-coordinates of points on the graph are multiplied by -1, but the x-coordinates aren't changed. This causes the graph to reflect across the x-axis, opening down and to the right. Here's an example of a reflection in combination with other transformations. First, multiply the function by -1, and the graph is reflected across the x-axis. Then replace x by x minus 2, and the graph is translated 2 units to the right. Finally, add 1 to the function, and the graph is translated 1 unit up. You can make the graph open down instead of up. If you replace x in the function with negative x, the x-coordinates of all the points are multiplied by -1, and the y-coordinates are not changed. This causes the graph to reflect across the y-axis, opening up and to the left. Here's an example of a reflection in combination with other transformations. First, replace x by -x, and the graph is reflected across the y-axis. Then add 1 to the function, and the graph is translated 1 unit up. Finally, replace x by x minus 2, and the graph is translated 2 units to the right. You can make the graph open left instead of right. You can use combinations of transformations to create complex variations of the parent function. For example, in the first graph, a function is reflected across the x-axis, then translated 2 units left and 1 unit up. In the second graph, the function is translated 2 units right and 1 unit up, and compressed by a factor of 1/2. Here are 2 more examples. In the first graph, the function is translated 2 units left and 1 unit down, and then stretched vertically by a factor of 2. In the second graph, the function is reflected across the x-axis and the y-axis, then translated 3 units right and 1 unit up. This lesson showed how to graph function families with transformations. And this lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.